Hello, my name is Simon Yarrow, and I would like to welcome you to our presentation. As you can see, we are Group 5, and we are working on quantum computing. So, let me introduce you to our team. Here is our team. There are 5 of us, and we have called ourselves Nemo Development, which is not, in fact, a reference to the Disney Pixar fish, but the original meaning of the word Nemo. Now, our specific interest, as you've seen, is in quantum computing. So let me try to give you a very brief rundown of what quantum computing is, bearing in mind, of course, that it is a very complicated subject and we are not quantum mechanics students. So it's just a very brief rundown, very simplistic, but hopefully it can help you understand a little bit what we're talking about. So quantum computing is basically the future of computing. It may be the future of computing hand in hand with classical computing. Quantum computing is very fast and it can handle a lot of data very quickly. The reason for this is that quantum computing, instead of using bits, which you know of, a bit of data is either a 1 or a 0, on or off, true or false, it uses quantum bits, or qubits, as you can see there, spelled with a Q. And qubits can also exist not just in on or off binary positions, but also in quantum superpositions, which means that they can be in multiple positions at one time, which I am not in a position to fully explain to you right now, but as you can guess, with more than 2 possible positions or states, more data can be handled and more processing can occur, and the more qubits that you use, of course, this grows exponentially. So with this speed, one of the benefits of quantum computing is it's very, very good at things like predictions and modeling. For example, predicting weather patterns, anything like that where you're going to use many, many different data points of different types and put them all together, incorporate all of them to make one single big complicated prediction or model. Another benefit of quantum computing is security, because one of the qualities of qubits is that they change state when observed. And so if someone were to try to observe your data while it was being transferred in some way, or I don't know, on your computer in some way, that data would change. And so they would not successfully steal your data and then be able to replicate it. However, with quantum computing, you have to bear in mind that it's very, very sensitive to noise, any kind of interference, because of course we're operating at the subatomic level. However, it also releases heat, so there's a bit of an issue that is currently being worked on, as you know, at keeping the system cool enough to function properly without error, while not introducing it to an environment that can introduce error. And as you may have heard with companies like IBM, where quantum computers do exist, one of the things you can do right now, you can't get a quantum computer in your home, but you can get data processing from a quantum computer remotely, because the issue isn't data transfer. You can transfer your data to them by typical means, but then you want the data processed at quantum speed, and you can now do that remotely. So hopefully this gave you some sense of what's going on, and now I'm going to pass you over to Mervat, who's going to start introducing you to some of the specific topics within QC that we have chosen to look at for this project.
Thank you, Simon. Hello, this is Mervat Mustafa. This slide shows the 3 subtopics under quantum computing emerging technology which we as a group have chosen. These topics are as follows in reverse order of preference. Topic 1, quantum machine learning. Topic 2, quantum supremacy. And topic 3, which we are interested in, quantum chromatography. I'm going to give you a small introduction about the QML, which stands for quantum machine learning. Most of us have heard of AI and quantum computing, but have you heard of the quantum machine learning? Quantum machine learning is the intersection between quantum computing and AI that is going to change what the future looks like. Individually, they are amazing, but together, they are unstoppable. In simple words, a quantum machine learning is a field that aims to write quantum algorithms to perform machine learning tasks. To describe that a little bit more, let us examine this figure. When data points are projected in higher and higher dimensions, it is hard for classical computers to deal with such a large computations. Even if the classical computer can handle it, it would take too much time. Simply put, sometimes the classical machine learning algorithms are too taxing for a classical computer. Likely, quantum computers have the computational power to handle this taxing algorithm. Utilize powerful law like superpositions and intelligence to solve problems faster than their classical concepts. As a figure shows, QML performance is a lot more protective and efficient than CML, classical machine learning. The QML, quantum machine learning, could process the quantum data, which has 8 possible states. It also could process the classical data after it is transformed to QD or the quantum data. As this figure shows, these are some of ML application, machine learning application that QML, quantum machine learning, could improve and solve the problem of. In conclusion, we can say that QML will solve more problems than we could ever imagine. Thank you for listening. Now I will leave you with my partner, Shaun. Thank you.
Thank you, Mervat. This is Shaun McCrum. Let's move on to QS, or quantum supremacy. Now, the idea here is we have two competing technologies. We have classical computing and we have the emerging technology quantum computing. And they are in a race with one another to basically just see which one's faster. Tried and true technology is eventually going to be surpassed by quantum computing. And at that point, we will have reached quantum supremacy. It's defined as the point in time at which quantum computing can be accomplished in a way which outperforms classical computing by conceivable exponential values. Now, these exponential values are, say, a week versus 10,000 years. Well, Google set out to prove that they could do this with current quantum computing by developing a processor. This 54-qubit processor was used by Google to process an algorithm in 200 seconds, and then they simulated that same algorithm on classical computing, and it would take 10,000 years. But does that really prove we've hit the point where one's faster than the other based on a simulation? IBM says no. IBM says we're not quite there yet because they believe until we can perform tasks that are not even accomplishable by quantum computing versus classical computing, we haven't hit that point, because IBM says we can continuously add more hardware to the situation to accomplish tasks that classical computing versus quantum computing can accomplish. So Google had a limitation on their experiment where they had a limitation of how much hardware can be used and how much RAM could be used to perform their calculations based on what's currently available. IBM says, well, we can always make more hardware, so we can always do more computations before we can eventually hit a point where we can accomplish this task. Instead of in 10,000 years, we can do it in 2.5 days. Google can do it on a quantum computer in 200 seconds. So it's arguable whether we've actually hit that point or not. And the applications are here huge, because once we've hit that point where we have reached quantum supremacy, we are doing things better on quantum computing. And we can start to perform new tasks because it's more efficient and less costly to do so. And which leads us to our third topic, which is our preferred topic, quantum cryptography. Quantum cryptography is based on the idea that current cryptography is no longer valid. Now, current cryptography uses mathematical equations that are more and more complex to create encryption keys, which need to be decoded on the other side. Now, quantum cryptography aims to completely undo this model. Instead of using complex math, it's going to be monitoring states of qubits, which is basically enabling the use of quantum mechanics to encrypt and transmit data in a way which cannot be hacked until it reaches its intended destination. And that is going to be our preferred topic, and I will pass things on to Fajir, who will delve deeper into the subject for us.
Hi. As my group members have said, our topic of interest is quantum cryptography. But more specifically, it is quantum cryptography and its future as a viable market. Our rationale for opting for this topic boils down to the need to gauge how much potential quantum cryptography has as a market, and to understand how we might be able to take advantage of this market as developers. As software developers, it's usually not enough to design and create applications that do what they were made to do. it's also important to take into account the security of our applications. According to this graph by Markets and Markets, between the years 2020 and 2025, the market for quantum cryptography is projected to grow from $89 million to $214 million with a compound annual growth rate of 19.1%. This is proof that the quantum revolution is picking up speed, and Gartner predicts that 20% of organizations will begin budgeting for quantum computing projects by 2023. However, the potential security issues associated with quantum computing have motivated enterprises to begin preparing for its arrival. This is because many companies in many different industries depend on the security of their data as well as the data of their customers. As a result of this, investments in quantum cryptography as well as the demand for knowledgeable and skilled professionals in the field of quantum cryptography is likely to reach sky-high levels. These companies will be willing to pay as much as they can to as many people as they can in order to generate the supply to match this demand for security in a post-quantum computing world. Our research will aim to define quantum cryptography in detail and its history, how it works, the benefits of quantum cryptography to us and to normal users, existing early implementations of quantum cryptography by organizations like Google, determine how much of a viable market quantum cryptography is and how much it will grow in the coming years, and finally, the challenges that have to be overcome before quantum cryptography becomes a mainstream market. Now I'll leave it to my partner, Thomas, to discuss our research targets, sources, and references. Thank you.
Hello, I'm Thomas Parro, and I'll begin with our sources. We will use publicly available research papers, technical blogs, and videos. This will help us understand quantum cryptography and how it encrypts and decrypts. This will also help us understand how quantum cryptography compares to classical cryptography in terms of encryption security and decryption speed. We will use data available from cybersecurity firms. This will help with the depth and breadth of our problem. We'll use releases and research from quantum cryptography developers. This will help understand how they are anticipating and tackling the problem. We will use releases from companies that possess large amounts of sensitive data. Hopefully we will get an insight of their awareness, their preparedness, and how they're working with quantum cryptography developers to come up with a solution, if at all. Next, we will look at research targets. Fellow students, exciting and important news about the future. Cybersecurity concerns us all. Existing organizations with encrypted data, including government agencies, and the possible imminent risk. All web developers. Common to require login, but how revealing is data once logged in? Could it reveal answers to security questions or other sensitive information? Cybersecurity firms warn clients about the risk, also have access to the solutions. Quantum cryptography developers, a very important, very profitable use for quantum cryptography technology. And finally, we have our references.
Finally, we would like to thank you for your listening, and please feel free to ask us any questions. It will be our pleasure to answer you. Thank you.